Okay. That works. Okay. So let me start with a little bit of history. I first learned about KX software in 2003, and KDB Plus was not there yet. Q was not there yet. We had K, and our hosts probably know very well the software at that time. It was completely undocumented, but somewhere deep in the library folder we had that libk20, a tiny library, 100K, probably less than that. And I thought it was just an I/O library, which allows you to read and write tables. Cool. So I wrote a Python wrapper for this because we programmed in Python. We didn't know K. We didn't even know that libk20 was anything about K. It had there was about half a page of documentation of funny two-letter C functions. But I thought it was the world's fastest comma-separated value reader. And it was very good at it. I'm talking about up to a terabyte of data converting from comma-separated text to something usable in a matter of 10 minutes. That was cool. Okay, so we did that. Actually, we even shared it with KX. They put it on the website. Some people found it useful. And then KDB Plus happened. And guess what? No libk30. So what we had to do was, okay, well, you cannot load K into Python anymore. Okay, so let's put Python into KDB Plus, and that's how PyQ was born. Okay, so that was in 2006. Okay, so soon after we figured out, okay, now you have Python running inside Q. So let's make you can call Q functions from Python. That's good, but now you have Python inside KDB Plus. Why not call from Q call Python? And it turned out that we were not the first ones. As usual, Arthur thought about this about 10 years before we did. So he put this little documented feature that if you start your line with some letter and parentheses, then you switch to a different language. So I said, okay, cool. So we can switch to Python, right inside Q. So p parentheses was one. Okay, so 2012 was exciting time. Many new releases happened between 2007 and 2012. One of them was KDB 3.0, which was fully 64-bit, except for enumerations. And Python 3.0 finally materialized to the shape where it was interesting. So we put both those things into PyQ and called it PyQ 3.0. In 2015, the main complaint that we were receiving was that it's impossible to install PyQ. You need to figure out, because there are pieces that go into Q, there are pieces which go into L64, there are pieces which go, God knows where, into Python installation tree. So in 2015, we packaged PyQ in a nice, Python package. So now you can, if you're lucky, you can get away with single PyQ command, and it will install everything in the right place. Okay, and now we are 2017, and we are releasing PyQ 4.0. Actually, we released it last week. Today we released 4.0.1 because as usual, you test on one system. When you put it out, people decide that they must use Red Hat 5.0. So we fixed the Red Hat 5.0 problem and put it out 4.0.1. Okay, so suppose you are into image processing and you love Q and you think, it's marriage made in heaven. You have a vector language, and what is an image? It's a vector. So you want to do everything in Q, manipulate your images. So you start Q, and the first thing, well, you know that all you need to do in Python is load the library, import, well, there are plenty of libraries which deal with images. Well, we happen to use matplotlib. And in matplotlib, all you need to do to get your image is this. That's all. And there you go. Now, but you want this in Q. So, yes, you can read the data. Doesn't look as pretty as the previous slide, does it? Okay. So it's some compressed bytes. Well, if you're a real Q programmer, you probably would spend 15 minutes, write out, a few lines of Q code and decode this. But if you're not Arthur Whitney, then why not just reuse what other people did? Okay, so that's all it takes. That's all it takes to get image read function in .im namespace in Q. And in fact, there is I don't want it to modify. I just want to point. Yeah, there you go. Okay, so as you can see, there's nothing going on here. Okay, I just will put out a Python function which calls the image read function. The two extra lines, are just a technicality which we could probably get rid of. But the problem is that when you deal with files in Q, you start them with a column, and image read doesn't like that column, so you need to strip it. Okay, and then when you come back to Q again, you need to return proper object. Okay, the next line is a little bit more involved. It has to do with the way Q calls its functions. In Q, you really don't have functions which take multiple arguments, variable number of arguments. You fix how many arguments you want when you create your function. In Python, you can have variable number of arguments. So when we send this read image function into Q, it becomes a function which takes only one argument, which is a list. Okay, so we need a little wrapper, which enlists whatever it gets before passing it to Python. Okay, so and then we set in the proper namespace in .im.read, and there you go. Okay, so now you have, and this looks like native, honest Q function, which takes your image and returns your data nicely formatted. And it's 2 by 2. It's list of lists of lists. It's like 3-dimensional structure. If you can count, each cell here is 3 bytes. Okay. Now, is there any overhead? Well, 27 milliseconds took it to load the canonical image. Is it a lot or is it low? Okay, let's compare it to what it was on, when we did it in Python. Well, rounding error. Well, actually, it's not as that. Remember, there was a little call, capital K of X, on the previous slide. Okay, and what that call did. Actually, when you read the image in Python, you get all your bytes in one straight line, contiguous in memory. In Q, if you want to have multidimensional array, it's a list of lists of lists. Okay, so you need to cut it. And it turns out that this little wrapper not only called in that 27 milliseconds, right? In 27 milliseconds, not only called the Python function, but also had time to cut the result and present it to Q. Now, why shape hash-mark flat takes 24 milliseconds, I don't know. Sounds like a lot. Why pure memory operation takes longer than reading from disk? I don't know. But that's not the thing. Actually, when you call the Python function from Q in Py, everything happens at the C level. Okay, so there is no overhead. Sometimes even calling Python function from Q is faster than calling the same function from Python. Okay, so now you want to wrap it up and give it to people who don't even know that you took Python. So you create a library. You create im.p one. Okay, so this .p will tell Q that it should apply, the Python language to what's inside. Okay, and then people will just load im.p, in a regular Q prompt you would do \l im.p, and then you get this functionality. You can read, and you can save, and you can save in different format than the thing which came in. So here it came in PNG, you save it in BMP, and it works. Okay, and that's all there is in im.p. Okay. So the last piece, you see how we are inside im.p. So we want to switch back to Q. The last line, it just turns, again, we start with a function which takes a list, and we want to create, what Q recognizes as a verb. Okay, so as a verb, it has to be the edit function in the .q namespace. Okay, so that's it. That's all it takes to introduce a verb into Q, which actually calls Python inside. Okay. Now, okay, so you did. You got your image in Q. Okay, you do your fancy Q processing. You can readily get it back into Python. In fact, the same Python functions that worked on your Python data will work on the Q data. You see, there's no conversion. I just call im_show. Okay, and on the left is the old image, and on the right is the image which Q algorithm processed. So that's what 90 degrees rotation implemented in Q. Okay. So you probably noticed this funny input-output prefixes here, and you wonder why did I leave them on my slideshow? Well, it turns out that this is not a slideshow. This is an IPython notebook, which itself is Python code running inside KDB+. Doing all this fancy processing, and presenting your result in a nice HTML-based frontend. Okay, so to prove that we really have Python and Q process here, and it's the same process. Okay, I'm asking in this line, I'm asking Python, what do you think your process ID is? Well, 1887. I'm asking Q, what's your process ID? 1887. And z.f, it tells me that Q is just running a P script, a script which implements, all the functionality which drives this slideshow. Okay. Moreover, as KDB+ is running here, you can interact with it. Okay. So inside KDB+, we have IPython, which communicates with the browser, sends pictures back and forth. At the same time, it's fully functional KDB+ instance. Okay, so it has a port open. Okay, and you can do, for example, you do qcon. Okay, you can use qcon to connect to it and do something. Okay, so here you see this fancy syntax. This underscore, it just refers to the previous output. So that was my way to tell, what port is. So underscore is 1024, so that goes into qcon. Okay, and we pipe q command into qcon, and that's it. It's the variable is set inside my KDB+ instance. Okay. So now my talk begins. So what's new in the recent release? Okay. Well, let me just mention a few things which will not be on the following slides. One is we finally got around to improve documentation. So if you go to our website, which you will see on the last slide, you will get decent documentation. Not excellent, but at least something to it. Okay, so now when you're inside Py, you have a choice. You can do Python, you can do Q. Okay, and you can switch to Q prompt if you want. So now your Q prompt can look like this. Okay, so it's you get syntax highlighting, you can get context-aware completion, and you even have little status bar which displays how much memory you're using and what KDB+ version you're using, which tells you this slide looks a little bit dated. Okay. Now one of the things, Q loves operators. There are at least as many operators as there are special characters on the keyboard, and some of those operators are double, triple duty. In Python, we don't have luxury of having question mark. We don't have luxury of having exclamation mark. So, but it would be a shame not to use what we have. So we figured out, okay, well, there are shift operators. Let's make them do something useful. Okay. 3.5. Q programmers really hate parentheses. So it's, why would you just want to call a function. Why do you need parentheses? Okay, so if you use Python 3.5, you can avoid parentheses. Also, in the true spirit of giving the same character, multiple meanings, it's also a composition operator. It's a little jam that probably not every Q programmer knows that there is a composition operator in Q. Well, in PyQ it's really nice. Okay, so if you want to write, and this dot is real, it's a Q function. There's no Python involved here. Okay, this is honest to goodness Q object, which implements dot product. Okay, well, in Python we have strings. When we send them to Q, we have to decide, what do we want? We want symbols or we want character strings. And interestingly, in PyK, the default was, okay, you have a string, it becomes character string. Because we thought, with symbols, you cannot delete them, they live forever, you stay away from symbols. But, it turns out symbols are really great, you should use them a lot. So in PyQ, by that time, we've actually learned the right way to do things. So we did the right way. When you have strings, they should be symbols. And you should stay away from character strings. But if you actually want to get character strings, then you use different instructions. So K will give you default, and K.string will give you strings. Okay, now what if you've got colors, strings, but then you change your mind. Okay, colors.string. Okay, now also it was a pain to get ONs, OWs, from Python. They didn't really, you would have to do Q parentheses, put a string, it looked ugly. It didn't look what they call pythonic. So we introduced a pythonic way of doing things. So you want float, you want ON, you do k.float.na. Okay? And it's an A, I hope at least some in the audience understand that it's not an A. Oh my God. Hackers are here. Okay, so few things got better when we deal with NumPy. Somewhat you've seen, you can. In the previous slides, we just casually manipulated three-dimensional arrays, and you can send it to Q, get it back. It works. Okay. Now NumPy has, in my view, a horrible implementation of dates and times. For example, if you store months, you store them as 64-bit values. Why? I don't know. But some people like it. So we decided that okay, if you pass Q months to NumPy array, they should come out as what Python programmers would expect. This problem, the major reason why we called it 4.0 and not 3.9, because this is not really backwards compatible. If you want the old way and get just integers, that's what those months are, 0, 1, and 2. Then you have to you get it from raw data. So you go to months.data and you pass it to array. Now this is actually the right way. That's what you should do because here there's no overhead. Because months.data is the actual data which is stored in KDB+. It's not converted to 64-bit and start counting from 1970 for no reason. Here, what you got if you manipulate it from so here I took this array and added 17 years to it. Okay, my months got changed. Okay, so this is okay. Well, actually, we still have one through. Okay, complex numbers. Okay, probably few people will be interested in that. But it works. You know, you can set complex numbers to Q, get it back, and even apply complex math to it. Okay, path options. Well, that's one of the examples where Q shines and Python not so. But you can work on either way. Okay, no. Okay. Name tuples. In Python, you can have your lists, and the lists can have labels on it. Okay, so you can create a point which has, you know, X and Y coordinate. Okay, so now you can pass it to Q and pass it back. Okay, so what else? Oh, that's an interesting slide. Okay, adverbs. Okay, so we have a function q.over. Q.over is just what it is. When you type over in a Q prompt, you see that k parenthesis x/y. Okay, and why does it have to be that? Well, because it has to be a verb. Okay, so for it to be a verb, it has to be a function in .q namespace with 2 arguments. We don't need that in Python. But what we do want, if we have f/, we want it to be a variadic function. So we want to be able to pass 1 argument or 2 arguments to it. And now you can. Okay, so that's an example of how you can mix your Q and Python code to, in this case, to do the Pascal triangle. Okay, and that's it. So if you're interested, all it takes, you know, is a simple command. Well, again, if you're lucky, if you have your Python environment set up the right way and your KDB Plus in the right place, then it will work. But it does work for most people. So if your Q is in your home directory and your Python is reasonably well installed, you know, it will work. Actually, I think it works on a Mac just out of the box with the system Python and KDB Plus in your home directory. Okay, and this presentation is brought to you by PyQ kernel, which is a free add-on. And if you want to pay some money, you know, you're welcome to use the email address here. Okay, thank you.